Hello everyone, welcome back to the channel. Today we're diving into one of the most groundbreaking developments in modern defense technology, a system that could reshape future warfare and redefine national security strategy. Israel has officially unveiled a major breakthrough in laser-based defense, a new step in energy weapon innovation that promises faster response times, lower operational costs, and unprecedented precision. This announcement has captured global attention, and in this video we're going to explore what this technology is, how it works, why it matters, and what it could mean for the future of global defense systems. The goal is to give you a clear, detailed, and easy to understand review of this breakthrough and the transformations it might bring in the years ahead. Israel's development of laser defense has been progressing for years, but this new reveal marks a shift from experimental capability to near operational readiness. The system is described as a high-energy laser shield capable of intercepting rockets, drones, mortars, and potentially even cruise missiles. What makes this breakthrough especially significant is not only the speed of interception, but also the extremely low cost per shot. Traditional missile interception systems rely on expensive interceptor missiles. A single Tamir interceptor used by Iron Dome can cost tens of thousands of dollars, sometimes more depending on the variant. In contrast, a laser beam can be fired again and again, since its ammunition is electricity. This makes the cost of each interception drastically lower, meaning countries could theoretically defend themselves against large-scale saturation attacks without running out of resources. What sets this new system apart is the level of power it claims to generate and the distance at which it can engage threats. Most earlier laser systems around the world suffered from limitations in range, atmospheric interference, and energy stability. Lasers typically weaken when passing through dust, humidity, or clouds, but Israel's new development reportedly includes advanced stabilization, improved beam control, and more efficient power management. Although exact technical details are classified, experts believe the new design compensates for environmental conditions far better than previous generations. That makes the system far more reliable and suitable for real-world combat scenarios. Another important element of this breakthrough is integration. Israel has emphasized that the laser shield will not replace Iron Dome or other air defense platforms, but will instead work alongside them. This integrated approach creates a layered defense structure. If a threat is detected at long range, traditional missile interceptors can be used. If a threat is approaching rapidly or is small and difficult to track, the laser system can instantly fire and eliminate it. This combination of lasers and missiles provides redundancy, flexibility, and adaptability. It makes the entire defensive grid more resilient against sophisticated and unpredictable threats. In an era where drone swarms, loitering munitions, and asymmetric tactics are becoming more common, this kind of layered protection is increasingly important. The breakthrough also carries strategic implications. Defense systems traditionally focus on destroying incoming threats physically. Lasers, on the other hand, rely on concentrated light energy that heats and melts structural components of the target. This process can disable engines, burn control surfaces, or cause explosions in fuel or warheads. Because the effect is instantaneous and extremely precise, collateral damage is minimized. If implemented widely, laser shields could reduce the destructive impact of warfare by neutralizing threats before they reach densely populated areas. Some analysts argue that this could change the balance of deterrence, because if it becomes much harder for enemies to inflict damage, the entire strategic calculus shifts. The global reaction to this breakthrough has been significant. Defense analysts around the world see this as a major technological leap that could push other countries to accelerate their own laser weapon programs. The United States, China, Russia, and several European countries have been working on high-energy laser systems, but achieving stable, high-powered, and practical performance has remained challenging. Israel's announcement suggests that it may have crossed a threshold others have struggled with. If true, the global arms race in directed energy weapons could intensify rapidly. Nations might seek similar capabilities to avoid falling behind in defense readiness. Another crucial aspect of this development is mobility. Reports suggest that Israel is working on ground-based, air-based, and possibly even naval variants of the laser shield. This means the system will not be limited to stationary sites. Mobile units could be deployed to borders, conflict zones, or strategic assets. Airborne versions mounted on aircraft could intercept threats at higher altitudes, increasing range and improving stability. Naval versions could protect warships, ports, and coastal areas. The versatility of the platform increases its overall value and opens new possibilities for future operations. One of the biggest advantages of laser defense is sustainability. Traditional interception relies on continuous production of missiles, storage facilities, and logistical supply chains, but lasers fundamentally change that equation. As long as the system has electricity, it can fire. Solar energy generators or power grid connections can support the system. Over time, this dramatically reduces the strain on defense budgets. Instead of spending millions on replenishing interceptor stocks, militaries can sustain a laser-based system at a fraction of the cost. This could be especially transformative for countries with limited budgets but high security threats. However, this breakthrough is not without challenges. Lasers require a clear line of sight and stable atmospheric conditions for maximum effectiveness. While Israel claims to have mitigated many of these issues, real-world testing will determine how reliable the system is under extreme conditions. Weather, dust storms, and battlefield turbulence can still affect performance. Additionally, high-energy lasers require massive power supplies and advanced cooling systems. Ensuring these components work together consistently in combat environments will be a critical factor in long-term success. The geopolitical implications of this technology are also worth considering. If Israel successfully deploys its laser shield, it could gain a significant defensive advantage over regional adversaries. This might force adversaries to develop new offensive strategies, alternative weapon systems, or cyber solutions aimed at circumventing laser defenses. The introduction of such advanced technology often leads to countermeasures, resulting in a continuous cycle of innovation and adaptation. But for now, Israel appears to have taken an early lead in the race to operationalize high-energy laser defense. Another thing to consider is how this breakthrough will influence conflict dynamics. If a country knows its incoming rockets or drones are likely to be intercepted instantly and cheaply, it might reduce the effectiveness of terror tactics or asymmetrical attacks. This could save countless lives and reduce destruction. It might also shift the strategic balance toward defense rather than offense. However, there is another side to this argument. Some experts warn that stronger defensive systems can sometimes encourage riskier behavior. If a nation feels more secure, it might act more aggressively in certain scenarios. These debates will likely continue as more information about the system becomes available. The technological foundation of the laser shield is based on combining multiple high-power beams into a single coherent output. This increases power density and accuracy. It also helps the beam maintain its integrity over long distances. The system uses advanced sensors and AI-driven tracking to lock onto small, fast-moving aerial threats. Drones, which have become a major part of modern warfare, can be intercepted with exceptional accuracy. Even small quadcopters with low radar signatures can be targeted effectively. This ability to counter both large and small threats gives the system enormous strategic value. Another major highlight is the system's response time. Missiles and drones travel fast, and interception requires split-second decisions. Traditional interceptors take time to launch, track, and adjust trajectory. A laser beam, however, travels at the speed of light. As soon as the command is given, interception begins instantly. This rapid engagement allows the system to counter multiple threats in quick succession. Saturation attacks, where dozens of rockets or drones are launched simultaneously, become much less effective against a laser defense grid. In addition to military applications, the technology has potential civilian uses. Airports could use laser-based systems to prevent drone intrusions. Critical infrastructure like power plants, fuel depots, and communication hubs could be protected more effectively. Even border security could benefit from laser systems capable of disabling hostile drones or surveillance platforms. This dual-use potential increases interest in the technology and expands its future market prospects. Looking ahead, this breakthrough could mark the beginning of a new era. Energy-based weapons have long been considered the future of warfare. They offer speed, precision, and efficiency that traditional systems cannot match. Israel's successful progress in this field sets a powerful example for other nations. Over the next decade, we may see widespread adoption of laser defenses, leading to new doctrines, new strategies, and entirely new forms of conflict management. But for now, this announcement stands as one of the most significant steps toward that future. As we wrap up this detailed review, it's clear that Israel's laser shield breakthrough represents more than just an upgrade to existing defense systems. It is a technological shift with far-reaching implications. It promises cheaper, faster, and more effective protection. It could alter military strategy, reshape geopolitics, and push global powers into a new phase of technological competition. While challenges remain, the progress made so far is undeniable. Countries around the world will be watching closely to see how the system performs when fully operational and how it influences the broader security environment. Thank you for watching and taking the time to explore this major technological development. If you found the information valuable, make sure to stay connected for more deep dives into advanced defense technology, global military updates, and breakthrough innovations.